Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
The first question, I'll actually combine two questions, one by Anand Shanbhag and the other one by Faraz MR. Essentially, the two questions boil down to to Jeanette. We've heard a lot of some of the research that has been going on in the computer science space. You mentioned about the health space. When it comes to areas of huge societal impact, things like, say, the environment, say, even to the other question, to the matter of enabling the minority sections of society in participating and doing big stuff, what are some of the things that MSR is doing or could be doing that help create these huge societal changes and huge impact worldwide?
Is this on?
Yep.
Okay. It's actually a very good question, appropriate question here in India, because the Microsoft Research India Lab has a group called Technology for Emerging Markets that directly addresses using technology, using off-the-shelf technology to have societal impact, specifically here in India, but also other developing regions in Africa and so on. And the 99 Dots project that I talked about in using mobile technology to ensure that patients comply with the treatment, TB patients comply with treatment, is just one example of how this particular group is having direct impact in rural areas in India. There are many, many other examples. There are a lot of people in other labs who are interested in grand challenges, whether it be energy or genome sequencing. I already showed you about the stem cell prediction work. And so there's, because as Chandu mentioned this morning, we've got 700 PhDs or over 1,000 people in Microsoft Research, you can imagine the variety of research done, people with different disciplines beyond computer science who have a real passion for having impact on society through their research.
Thank you. So the next question is for you, Dr. Lamson. A lot of these folks out here will soon be entering initially programming positions as they grow in their roles, where they'll be working with large teams of programmers. What are some of your hints for building systems with large teams of people?
The most important thing is keep it simple. And the next most important thing is use abstractions, because that's really the only tool we have for being able to effectively deploy a large team of people. The essential thing that abstraction does for you is it makes it possible for people to work more or less independently. And if you don't have that, then everyone has to be able to talk to everyone else, and the cost of that is obviously going to go like n squared, and it's not going to work when n is bigger than 5.
Can I add something? I'd say the third most important thing is to write a spec. And that is to facilitate communication among the team members. And also when new team members come on board, they can read the spec.
Yeah, programmers tend to think that writing a spec is a waste of time. And as long as you can do the project by sheer willpower, that's absolutely true. The difficulty is that willpower doesn't work very well when the team is not very small, and it works even worse as the system evolves and has to change, because you're not smart enough to keep it all in your head.
So the next question is, feel free to clap if you, absolutely.
This reminds me of a story that I heard that Jimmy Carter, after he stopped being president, was going around giving speeches, and he was giving a speech in Japan, and he was having sequential translation, so he would say a few sentences and then he would pause, and the translator would translate into Japanese. At one point, the president told a joke. It took about 50 seconds. And then the translation was very short, and everyone burst into laughter. And he couldn't understand how could it be that this somewhat tricky joke had been translated into 3 seconds of Japanese. So he inquired afterwards, and he was told that what the translator had said, President Carter has told a joke, please laugh.
The next question is for you, Jeanette. This is more to do with your talk on computational thinking. When we learn math, we usually learn to do stuff, do the arithmetic stuff, before learning the deep underlying concepts behind it. What's the equivalent to computational thinking where what should we operationally learn first in order to imbibe the concepts of computational thinking?
This is a great question, and I have two ways of answering it. As a researcher, the way I would answer it is, we don't actually know. And let me explain what I mean by that. In centuries of learning mathematics, we've somehow figured out, well, first of all, before I get to that, we know by the time you're 5 years old, for instance, you have a sense of number. You have, in fact, the sense of greater than is shared by other primates. So you have a sense of number. By the time you're 12 years old, you have enough mathematical sophistication through the concepts you've learned and through the exercises you've done to learn algebra. By the time you're 18 years old, you have enough mathematical sophistication based on all the concepts you've learned beforehand to learn calculus. So somehow we know that. And somehow we have figured out how to, if you will, line up the concepts of mathematics so that we know what to teach you when you're 5, 6, 7, 12, 18, and so on. And there are research areas that study how to teach mathematics. So the researcher in me says, I don't actually know the answer to that question because we have not actually studied from an education science, from a cognitive science, from a learning science perspective, how to teach computer science. What concepts in computer science make best sense to teach at what age? When is the right time to teach recursion? I don't really know the answer to that question from a scientific perspective. Now, that's me as a researcher speaking. I'm not actually going to necessarily wait around for all the research communities to come together and figure this out, much as we have done in mathematics, which is a much longer, older field, or physics, which we have figured out since Sputnik. So the pragmatist in me says, well, intuitively, what do I think children could learn at certain ages? I think actually the computer science community is still trying to figure this out and laying down various curricula for different age levels. I do think there are certain concepts that one could teach pretty easily at young grades. For instance, when we teach how to do long division, we're teaching an algorithm. But when we learn long division in mathematics, at least when I learned it, my math teacher didn't tell me you're learning an algorithm of how to divide one number into another and get a quotient and remainder. And by the way, here's a way to check it, and that's a different, part of algorithms and so on. Had I been taught the general concept of an algorithm, maybe I would have approached mathematics differently. So the real point is, I think there are some concepts in computer science that I think everyone can benefit from knowing. I mentioned a few, like algorithms, like what a state machine is. Ideally, at some time you know, and maybe in high school you know what an invariant is. So then you can write specs. So I think this is exactly what the United Kingdom has taken a really good first stab at in terms of figuring out what concepts in computer science make sense to teach at which grade level.
So it's a nice lead into the next question, which is for Sid. This is from Chetnabi. So during the course of the day, we have heard a lot of mentions of how people with computer science skills can help other disciplines, biology, for instance, environmental science, health, so on. From a MEC perspective, what are some of the ways that we could be helping them take their skills that they have developed over their years of undergrad training to these other disciplines?
So from a MEC perspective, as we said during the talk as well, it's a platform where content and the way you use the platform plays a significant role in terms of how learning is improved. So to answer this question briefly, I think it's again, the platform itself is quite comprehensive, and if you have the right kind of content, which can actually come from people like you as well, it doesn't really need to come from, you know, only top-notch professors. If you guys and you think you can actually go and help the community in a bigger and better way, as you mentioned in the question, you can actually start creating content on your own, and in turn put it on, you know, platforms like MEC for others to kind of go and make use of it and learn from, you know, such technologies.
So I think that's a good question to throw out to the audience. We have so many of you guys here. Some of you have already used MEC, some of you who haven't. What are some of the things that you want? What do you want to learn? What's the content that you want to see? What are the disciplines that you want to focus more on? What are some of your thoughts about how we, both the research community, MEC in specific, and the research community in general, could be helping you guys with? So, like, what would you like to see on MEC? Just raise your hand maybe, or shout out something, and we'll react to it, or Sid will react to it.
What did you say? One-day course?
One-day course, or shorter courses. What else?
Come on, speak up, whatever you guys think. Yeah.
Yeah.
So you mean to say more practical skill testing platforms like coding within the MEC platform and such. So good you raised that. So actually on that note, within Microsoft Research across various labs, there are a lot of researchers who are working on problems which are very similar to what your friend just mentioned. So in future, we are trying our best to see what all of these different technologies across different research groups can we bring together and put it on MEC to kind of do the kind of stuff that he just mentioned. So you are right, and point well taken. We are trying hard, so hopefully maybe in the next few months you will see more and more improvements coming on the platform.
Any more hands? Maybe around the back. There's another hand there.
There's one there.
Yeah,
one
go ahead.
So more animations within the videos, not straight animations. Yeah, so that's again a feedback we have heard, especially from faculty. So yes, we are working on that as well. So the next course that you see will actually have a lot of those things already incorporated into the videos. There's one hand.
The core subjects like operating system or compiler design that we already teach, like electives are something which require specialization, something like computer vision, natural language processing. So if courses are available on such elective subjects, it's good for faculty and even students.
So a valid point again, but on that note, one of the challenges we have faced, I mean, we'll be very honest with you, one of the challenges we have faced over the last 2 years is creating quality content. So I think we have a lot of faculty here. We would actually request all of you to come join us as community and start creating content. So if you can create content, not only will your students benefit, we can put it up and open it up for the entire country and all other people from across geographies to kind of look at it. So we want to do it, we are open to doing it, but we need your help. So I would request all of you to get together and probably help us create more content and put it on the platform.
We have 30 seconds left, so one more question. Let's see, I saw your hand first.
Students should be provided some sort of industrial glance of the knowledge that they seek through MEC. That is the actual application in industries, because it will give them practical as well as theoretical knowledge. So that's another suggestion. Okay.
Another feedback, well taken, yes.
Well, thank you. We are out of time for the Q&A. I'd like to thank our panelist speakers once again.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.